And this is NSM Customer Success, QoE, L3VPN, and NAT64 OMI. My name is Bruce McDougall. I'm a principal architect at Cisco. This effort was a collaboration with Dan Bernier from Bell Canada, and then Zia Syed as the original developer for the proof of concept of the Jalapeno project that underpins some of the work here. So I'm going to quickly go through an agenda. In 2019, at the NSM Con in November in San Diego, essentially a collaboration was born. Then go through Bell Canada's goal to transform themselves and their services to cloud native. And then an SDN problem statement. The network black box is kind of the barrier to a lot of SDN use cases, we feel. And then I'll do an overview of Project Jalapeno, which is our generalized SDN proof of concept platform. And then the collaboration with Bell, how it's basically how we're putting together NSM and Jalapeno to build a cloud native layer 3 VPN NSE. And then there's also kind of some roadmap NSEs that, that the title alludes to with the quality of experience in NAT64. And finally, a summary. So, like I said, collaboration was born at NSM Con 2019. At NSM Con in San Diego, Dan Bernier from Bell Canada presented essentially an architecture, a desired architecture designed to build out a cloud native service provider or telco services. And he felt at the time that leveraging SRv6 as the underlying data plane would be a very valuable method to approach this. And what he wanted to do is convert essentially NFV kinds of functions or VNFs to cloud native. And a key problem statement that he articulated at the time is the need for tight coupling between cloud and metal. Earlier in the day, oops, sorry, forgot this was a build. Earlier in the day, Zia and I had presented on our proof of concept project, Jalapeno, which at the time we were kind of thinking of it as an SDN sort of proof of concept project that could execute like quality of experience use cases for cloud native applications. So you could do traffic engineering essentially. And the two together, after Dan presented and after we all got talking, we realized that these two projects are completely complementary. So we essentially made arrangements for a trip to Montreal like 2 weeks later and had a day of whiteboarding, and things got launched from there. So Bell Canada's ultimate goal is to move to, like I said, cloud native telco services. And there's some key requirements there to execute on that goal. First of all, the application workloads themselves need to be able to request, say, network service contracts, things like security or an SLA or a VPN. And then we need to be able to abstract the complexity of the network away from the user or the application, the workload itself. And then the third requirement is that the network should dynamically adapt to changing conditions within the network itself. And then Dan also articulated, or Bell has also articulated, that this sort of move toward application responsive networking they felt is very achievable via implementing a unified forwarding plane, segment routing end to end, essentially. But then, like the earlier slide mentioned, there is that gap. It requires bringing SR to the application workload itself. And so what they've articulated as the software edge. And really, if for non-network engineers in the audience, in the service provider world, the network edge is kind of, it is the end of the service provider network, BGP environment. And anything beyond that is, say, is customer, so to speak, or potentially application. So that software edge means that the service provider network actually needs to be extended into the server host itself, which leads very nicely into the SDN problem statement itself. This is from Zia's and my presentation previously at NSM Con, where we articulated, with Project Jalapeno, we articulated the exact same problem space that Bell Canada had. Looking at SDN use cases, you've got applications and people or stuff that applications would like to communicate with. And in the middle, you've got this giant network black box. And so from the application's perspective, this is how the world works. And maybe you've got some SDN controller up there. So the application makes a request to the SDN controller. The SDN controller is a network-centric SDN controller, so it executes some magic within the network black box, and the application is left to wonder if it worked or not. So that's the gap that Bell Canada and our team are looking to close. And so Project Jalapeno is specifically designed to do that closing of that gap. So Jalapeno is a proof of concept project that Zia and I and a couple other folks have been kind of working on for about 2 years now. And we articulate some very specific principles guiding the project. First of all, that SDN is not about controllers and protocols. It's actually really about databases and APIs. And number two, we want to give applications the ability to directly choose their service. And this maps perfectly with what Bell Canada wants to do, where they want to also essentially do exactly that. And we want to, from the ground, from the get-go, we wanted to expose those service attributes via an API as opposed to, say, some, make it available via like a PCE protocol or something like that. Ultimately, those three, we look to eliminate the network black box. We want to perform the SDN encapsulations at the server itself. Jalapeno has also been designed from day one to be microservice-based. It's Kubernetes-based from the outset. And for best results, we want to ideally combine network and application performance data. I'm going to kind of whip through these slides for the sake of time, but Jalapeno is architected sort of in three main pieces. There's a data collection stack where we're collecting network topology and network performance data. And we aggregate that data all through Kafka, which is pretty natural. Then we've got a series of data processors that we've built where they're taking the data off of Kafka and mapping that data, both the topology and the performance data, into a series of virtual topologies in a graph database. And Tim and John in their talk earlier mentioned, or I think there was some discussion of graph databases, and this is very, very powerful and useful, where essentially we've taken the network topology itself and we can map it into n number of possible virtual topologies. So there's the underlay topology itself, like say if you're running ISIS or OSPF, but every VPN is also a topology, a virtual topology in this data set. And so with Jalapeno, the goal is then to expose those virtual topology data sets via an API gateway. And from there, a little bit more build, an application or end user or host or whatever could be seeking to request network services, make that request via the API gateway, and the API in turn, after some mining of the database, can respond back with a label stack or say an SRv6 SID value that can then execute the use case that the application requested. So with that bit of background, with Jalapeno essentially looking to close the network black box gap, or that service edge gap where we extend the network into the host, we can now combine Jalapeno with NSM and try to create network services that do exactly what Bell Canada wanted to do. So here I've got a diagram of essentially an example network. I've got customer sort of on the left, connected via a service provider router. There's a metro network, say a central office data center, and a wide area network. And in our first use case, Bell Canada wants to be able to connect a workload that's, say, in this server here to the VRF instances that this customer is participating in. So this could be, say, you want to connect like something like a firewall VNF or something like that. So the first thing we do is we've actually built a layer 3 VPN NSE. And that layer 3 VPN NSE has, as in Tim and John's presentation, as well as in Ed's discussion, it's got a decoupling of control plane aspect and data plane aspect. So the layer 3 VPN NSE has a VPP that it comes with. Now our containerized VNF in an NSM context, it spins up, and as it spins up, it's going to request to join VRFs red, green, and yellow. So It might just request to join a single VRF, but in this case, we actually built it out to be able to join multiple, as Bell has use cases for that kind of thing. And in our case, the NSE may be co-located on the same server host as the client for performance reasons, although it's not a requirement. Here's some sample YAML for the client's request, and just to highlight down here, the Layer 3 VPN NSE request for VRFs to join. So as the system works, the signaling and VRF programming, after the client makes its request, NSM is then going to signal to our Layer 3 VPN NSE, which has pre-registered, to attach the client to its VRF instances. So the NSE will then essentially, it'll plumb those interfaces to the NSM forwarder data plane or cross connect that got established. Next, our Layer 3 VPN NSE, it doesn't have the Layer 3 VPN BGP table itself. It's not actually a BGP speaker. What it does is it queries Jalapeno, which has the VRF fib tables already. So it asks for, give me essentially all of the destination prefixes in VRFs red, green, and yellow. Jalapeno responds back with that data set and corresponding, in this case, SRv6 SID values to execute the VPN encapsulation. And then the Layer 3 VPN NSE programs VPP with SRv6 VRF instances and SID values for performing the encapsulation. So at this point, we've actually established that now the client has essentially a routing table for all three VRFs and can send outbound traffic to, say, the customer end in VRF red, and also to, say, endpoints on the green and yellow side. But now we need to establish a connection back, or the ability for those endpoints to communicate back with the client. So the next step is the Layer 3 VPN NSE. It'll signal to a GoBGP instance that's running in our cluster to issue a Layer 3 VPN advertisement of the client's subnet on behalf of, essentially on behalf of itself, to the remote PEs. So that BGP advertisement then flows through the network via route reflectors and things like that, and remote PEs get it and program their forwarding. And now we've got end-to-end bidirectional communication established. So the client has joined the Layer 3 VPN instance. And I wish I had a demo to show you all, but because of scheduling and such, we're not ready for that. Hopefully we'll try to post something though at some point. So that's currently in proof of concept and in our lab and in Bell Canada's lab, and we're actually targeting a initial sort of a canary production deployment by the end of the year in Bell Canada's network for the Layer 3 VPN NSE and this service. And then on our to-do list, the stuff we have coming up next is we want to be able to add like a quality of experience traffic steering to that Layer 3 VPN service. So let's say for a certain given set of prefixes, if it's high priority traffic, we want it to take the best path, or the lowest latency path, or whatever path has the attributes that achieve that high priority SLA. And let's say for low priority traffic, let's say for backup traffic or something like that, we can actually steer that traffic off of the best path to a lesser utilized and less important path. So those are goals for the quality of experience traffic engineering. And then also Bell Canada has a use case for a NAT64 NSE that can simply do translations from 4 to 6 and vice versa. We also have brainstormed any number of other use cases or NSEs that could make use of the combination of NSM and Jalapeno's virtual topology data sets. So more to come. So in summary, Bell Canada's application responsive networking goal, again, I'll kind of sort of restate their requirements 1, 2, and 3. The first requirement being that the app can request some network service contract. And then the network also, the constructs must be abstracted away from the application workload. So in this case, NSM provides that abstraction and menu of services, and then Jalapeno provides the virtual topology mappings that can execute those network services. And NSEs can leverage or program encapsulations or forwarding via the data set that Jalapeno replies with to any request. And then the layer 3 VPN NSE itself completes the connectivity between the client and those VRF instances. And again, to highlight, we're doing this with SRv6. The third requirement, that the network should dynamically adapt to application-specific patterns. So within the layer 3 VPN NSE, if prefixes are deleted or withdrawn or added to the VRF instance itself, the Jalapeno system, its database updates, and the layer 3 VPN NSE also updates. So from a straight layer 3 VPN aspect, the network and the NSE do dynamically adapt to those kinds of changes. As far as, say, performance changes or SLA changes within the network, like I said, that is kind of phase 2 of the journey, where we look to do quality of experience engineering. And then number 4 and 5, this is achievable. We've demonstrated that this is very much achievable with segment routing. We've done proof of concept with both segment routing with MPLS labels, if you will, at the VPP, as well as segment routing SRv6 with SRv6 SID encapsulations. And then the Bell problem statement that it requires bringing SR closer to the application workloads, which matched the Jalapeno problem statement that the network is a black box, by moving that network functionality, that encapsulation functionality, directly into the server host. We now have the ability with network service mesh to attach those workloads directly to their VRF instances, or potentially like an SLA forwarder and that sort of thing. So confirmed there. And with that said, I kind of blasted through this, but wanted to give quick acknowledgements to the team. So obviously Mr. Bernier from Bell Canada, Zia, who is the initial developer on the Jalapeno proof of concept. Sergey Bezverky is a Cisco developer in Montreal who built our layer 3 VPN NSE. Terry Couture is the lead architect for Cisco on the Bell Canada account. And then Ed, our NSM Oracle. And the entire Cisco SRv6 engineering team has been executing, and they contributed code to VPP for SRv6 encapsulation as well. So with that said, thank you for our sponsors, and that is my talk. Do we have any questions?
So there are some questions in the chat.
Okay.
So basically, Rashini asked, are these NSEs planned for upstream to the NSM project?
The NSEs, I don't know yet. They're considered at this time, I would consider them Bell Canada's intellectual property. I mean, they're paying essentially a service contract for Sergey to build them. Jalapeno itself, we plan to upstream here pretty soon. Not to the NSM project itself. It'll just be a separate organization and set of repositories. But yeah, the NSE side is a TBD.
Well, it looks like that answered Rashini's question. And then we had a similar question from Michael Hernandez on the Slack NSM channel. L3VPN NSE code has public access ? Documentation / code POC is available ?
I would love to make it available. So I'll talk with Dan about that when he gets back and see what he wants to do. Because that would be pretty cool.
Yeah, I would love to see something like that in the repo as well. In short, if you don't open source it, it's very likely that there will be other groups that'll rebuild the same type of behavior and open source it as well. And so open sourcing that, I don't think that specific component, I don't think is your core source of value, but rather the additional services you provide around it and your reputation as a company. So I would love to see something like this hit the repo if you're able to make it happen.
Yeah, cool.
Yep. And just to be clear, I don't think anyone's terribly religious about what repo things land in. But if it does land at an open source repo, I think we need to start actually getting serious about collecting pointers to things, because we're starting to get enough people doing enough interesting things in various repos that are not part of the network service mesh org. And that's actually a really healthy sign. So like, it's more power to everybody who's doing that, but being able to find them is sort of an important thing for the community.
Yeah, great point there.
Yeah, this was, I'm sorry, please continue.
I was going to say for Jalapeno, when we do open source it, we'll definitely include pointers to NSM, because it's been a terrific collaboration between two projects that are, you know, highly complementary. But you were going to say, Frederick?
I was going to say, this was a fantastic talk, by the way. Like, I'm really glad to see how things have progressed since, was it November of last year? So fantastic progress from you and your team.
Thank you. Yeah, been really excited. The team has done great work.
Looks like we might have another, somebody's typing something in Slack.
Okay.
Another question would be fantastic.
I haven't connected to Slack. Apologies.
The typing disappeared. Anyways.
Okay.
Cool. Thank you very much for the presentation. So that there was a question: is Jalapeno open source? They mentioned they plan on trying to open source it. Is that correct?
Yeah, goal is end of August. We're talking with some folks in legal here later this week, actually, about some specifics that we need to do to get that done.
Fantastic. And there's one more person. I can see that they are typing on Slack. So let's give it a brief moment more. Just a thank you. Yeah, and thank you for attending a bit, and everyone else as well. Cool. Yeah. So that concludes our line of talks. Do you have the energy to open it up for a few last set of questions in general?
Absolutely. I always love questions.
Cool. Well, if anyone has any questions, we still have several panelists on the call who have helped, and Ed and I are willing to answer questions as well. Well, I'm not seeing anything at this particular point. All right, well, in that scenario, just as a reminder, you can visit us at networkservicemesh.io. And all of these talks and their presentations, Ed and I have been uploading all the slides that we have to the events page in the networkservicemesh.io website. If you are a presenter and you haven't sent it to us and you wish to have your presentation in the website, please let us know. We'll put it up there. And we also intend to make it easier to get to some of these videos in time. So the video was live streamed on YouTube, and so you should be able to visit that same link and see the recording in its entirety. And hopefully in the near future, we'll be able to break these out into their individual talks to make it easier for people to discover and listen to. And
so you can sort of see, I've got on the share right now, sort of where the slides have landed. Being firm believers in localization, the place you went to go get all the information about the talk on the website is exactly where the slides land, and that's exactly where the individual video links will land as soon as we get a chance to edit that into the appropriate pieces.
We also have included GitHub and LinkedIn and Twitter information when available in case you want to reach out to people. And of course, you can always reach out on Slack. The NSM channel that we directed everyone to for this talk is very active. And if you ask a question, we have people around the world who are working on NSM. There's very likely you'll get an answer in relatively good time if you hop in and join us and ask questions. And so we also have our weekly meetings every Tuesday at 8 a.m. Pacific, except for this week. This week we decided to pass because of NSM Con. But next week we'll be back on our normal agenda, and we hope to see all of you there. And with that, I want to thank everyone for your time, and you all have a fantastic rest of your day.
Cool.